lower trucks pop lighter and higher trucks pop higher. Scientifically, are they really correct? Key points. 1. The height of the trucks and the force required to start tilting the tail are almost unrelated. 2. Based on calculations, with a difference of 5 mils, the tail can reach the ground with 9% less force with lower trucks, and the popping force can be 10% stronger with higher trucks. And 3. It also affects the turning ability. Let's look at each of them. First, let's examine the saying that lower trucks pop lighter. Since multiple factors are involved, we will separate it into 2 parts. The force required for the tail to start going down, and the force required for the tail to reach the ground. Let's begin with the first one. When you pop, the board begins to rotate around the rear wheel's axle. And yeah, it seems like the lower board might pop lighter. There is physics behind this, but the shape of a skateboard is somewhat too complex to explain it, so let me give you an example of an object with a simpler shape: a door. When you push it, it opens around the hinge, just like a skateboard rotates around the axle. In that sense, although there are some differences in the shapes, the same basic principle applies to both. That said, imagine an L-shaped door. The force needed to start opening the door does not change with a flat door, despite the difference in shape. The same can be said regardless of the length of the vertical part of the door. No matter how long the vertical part is, the door starts to open with the same amount of force. It does change, however, when you push closer to the hinge. The point is that the primary factor determining how much force it takes to open the door is where you push, not the door's length. A skateboard works in a similar way. Increasing the truck height is like making the vertical part of the L longer. As long as you pop the same spot, the force required to start tilting the board remains the same. So, the height of the truck does not change how lightly the tail starts to tilt. The required force changes only when you change where you pop. Where in practice, changing the truck height also changes the weight. However, the mass difference between typical high and low trucks is only a few tens of grams, so we will exclude it this time. Next, let's consider the force required for the tail to reach the ground. Assume the truck height differs by 5 mils between high and low trucks, and the distance from the axle to the tail is 20 centimeters for a low truck. And the time to complete a pop is 0.1 seconds in both cases. If you calculate it, you can see that the tail reaches the ground with about 9% less force with lower trucks. 9%. 9%. I am not saying it's meaningless, it's just that the difference in the lightness of pop is so subtle that I personally couldn't feel it. Now, how about the saying that higher trucks pop higher? To begin with, what matters most for a stronger pop is how forcefully the tail hits the ground. For that to happen, the tail must accelerate sufficiently before hitting the ground. Assume you apply a constant force to the tail until it reaches the ground when popping. The higher the trucks, the farther the tail is from the ground, which means it has more time to accelerate before impact. I know, the actual pop is more of a momentary, instantaneous snap, and the force after the first moment doesn't remain constant. It should rapidly decrease. But this topic is so complicated already, so to simplify it, we assume it remains constant until the end. This is the formula to calculate the energy acting on the tail just before impact. If you use the same board as before, the energy is about 10% greater with higher trucks, meaning the tail hits the ground more strongly with higher trucks, potentially allowing you to ollie higher. Why potentially? Because this calculation applies when you continue to apply the constant force to the tail. Next, let's see the effect on turning. Higher trucks allow you to angle the deck more deeply. Being able to angle more deeply results in a tighter turning arc, enabling quicker turns. In addition, higher trucks greatly reduce the chance of wheel bite. In summary, in turning, higher trucks definitely feel better. And in lighter pop, lower trucks give you 9% lighter pop, and higher trucks give you 10% higher pop. But the most important point is that even if the board rebounds higher, that does not directly determine the height of an ollie. For example, if the front foot does not move above a certain height, the board cannot rise higher than that, no matter how much upward force it has. What allows you to lift your board higher is the friction generated when the nose pushes back against your front foot, which can be stronger or weaker depending on the height of your trucks. And seems to me that has more impact on the feeling of an ollie. On the other hand, for tricks like a pop shove it, where the front foot leaves the board instantly, the stronger pop from higher trucks may be more beneficial. But higher trucks also mean you must pop deeper to hit the ground and require more precise control. Lower trucks make it easier to hit the ground, potentially making tricks like pop shove it easier to pull off. After all, it's only a 10% difference. I personally am not good enough to notice such a big difference. Lastly, please note that this video contains many assumptions and simplifications. Please consider this as a reference. And that's all for this episode. Thank you so much for watching. Until next time.